To introduce myself, as it says up there, I work for ThoughtWorks. I'm a developer out of our San Francisco office. And I'm going to be talking to you about some work that I did for GoCD, working on an analytics offering. ThoughtWorks, you might have heard Martin Fowler, read some of his books. We're a global consulting firm focused on helping clients solve whatever tough technical or organizational problems they have, working with clients everywhere from small startups where tech is the core part of their business to larger enterprise organizations working in finance or travel, where maybe tech isn't the core of their business, but it's now a really important part of what they're doing, as, quote, software eats the world. And GoCD is a continuous delivery tool developed by our Studios division, which builds agile software. I wanted to begin with this quote because I think it emphasizes the importance of metrics in really every domain right now. Peter Drucker, who's this famous business author, says it's impossible to improve what you can't measure. And I think intuitively this statement resonates with all of us. How do you know if you're actually growing if you don't have the data to understand where you've been and where you're going? So I'm going to be talking about the importance we see in metrics, particularly in continuous delivery, but I think it's important to acknowledge that there's kind of a metrics mania across every domain. We see this with the value placed on things like the Net Promoter Score, which asks how likely you'd be to recommend a product or service to a friend or someone you know, with the widespread adoption of tools like Splunk that offer performance monitoring, the focus on Google Analytics and understanding every user behavior and every site interaction. How long do users spend on a single page? Where do they look? What are they engaging with most? And even with the quantified self-movement, right now I'm wearing a Fitbit, and there's this desire to kind of understand how you're performing in every aspect of your life. I'm going to be talking specifically, though, about metrics in the context of continuous delivery. The project I was working on that led to this research was focused on, as I said, GoCD, developing an analytics offering that would provide coaching within the tool about how well you were using the system and areas for improvement. And so we started with this one mission for the GoCD analytics team, which is how can we help teams understand and improve their continuous delivery processes? So to begin, we had to define what is continuous delivery. And I think because it's such a broad and nebulous term and you have a lot of different meanings, even in a crowd like this where everyone's practicing continuous delivery and trying to improve their daily processes, it's important to start with a shared definition. In our eyes, continuous delivery is basically about building software so that you can routinely release to production. Whether or not you're doing releases every couple of minutes or you're gated for some reason by users who don't want to adopt your changes every single second. We were having a discussion upstairs about how to handle pipelines where different clients want to pick up code at different rates. But it's about having your code in a consistently deployable state such that you could release and that your builds are passing, you're ready to go. Maybe that release step is still gated, but the code itself is ready. It's also about being able to get fast automated feedback. The last thing you want to do is find out that there's a bug in production because someone comes to you and says, hey, I was trying to access this page. You want to be able to catch it early on, and so having robust monitoring is also a really important part of this. And ideally, you want to be able to do push-button deployments. I've worked on clients where you had to get leads from every single team, and it was like 10 different teams in a room. Everyone has their own checklist, and if anyone goes on vacation, maybe their checklist is somewhere, but you don't actually know where it is. And that means that you can't release until they get back from vacation. So that's a bad state to find yourself in if you've got a single blocker because they have to do a manual sign-off, and they're the only person who knows how that works, and the only person who knows what you should be checking. So ideally, you can do a push-button deployment. And so how do we identify what metrics matter? What let you know if you've actually achieved a good state of continuous delivery? We went the old-fashioned way, and we did something kind of radical. We talked to people. So we did a lot of interviews. We interviewed consultants. We interviewed developers. We talked to operations folks at every intersection of DevOps, DevSecOps, kind of every iteration you see. And we also talked to folks from the business side because part of doing continuous delivery is being able to talk to business stakeholders and being able to communicate the value of some of that underlying work that I think we in the room all buy into, but maybe your business side folks don't. And part of what's really important for being able to get the time to do this stuff right is being able to make the case to the business stakeholders. And after we did those interviews, we also did some contextual observation, which is basically where you sit down with folks and you have them walk you through their workflow and talk about the pain points. You're asking questions, asking about the context, where they feel like things are going well, where they're hitting some sticking points. And we synthesized all of that with a ton of sticky notes. I saw someone tweet earlier that they wish they'd invested in Post-its or invented them, and I absolutely agree. 3M is probably doing very well right now. And then we did some rapid prototypes, so really quick sketches to try and get feedback, because people feel a lot better about telling you your idea sucks if it's only sketched out on a page than they do after you've actually invested in building something with real code. And then once we'd synthesized all of that feedback, we moved on to developing a pilot offering that a couple of Go's customers could actually implement and use in their software, and got some more feedback out of that. And out of all of that research, there are 4 metrics that we synthesized out of this that we think are really valuable. And I'm going to talk in turn about each one, and then as I go, discuss some case studies of how we've actually been able to see improvement in these areas. The first is the number of deploy-ready builds that you've got. The second is the cycle time. The third is the mean time between failures. And the fourth is the mean time to recover. So these are all pretty straightforward, but very powerful, and sometimes, admittedly, hard to track if you don't have good baseline data. But thinking about them and getting buy-in to them can really be a powerful thing. To start off, we've got the number of deploy-ready builds. And by this, I mean how many builds are ready for production. And there's a lot of stuff that goes into this. You have to have routine commits, and specifically routine commits to master. If I'm committing all the time to my own personal branch, I'm not adding value to the code that's actually ready for production. And so having it be off here and someone else is working over here and those aren't getting integrated, none of those things are really ready to be deployed. It's also about having testing you can trust. In one of the case studies I'll be talking about, this is what I'm living day in and day out on my current project, you have testing where maybe you've run it for several hours, and so you've taken your whole day to do all this validation, and at the end of that, you're no more certain than you were at the start. And that's really costly because it makes everyone very wary of ever releasing. You've done your 8 hours of testing, and still we don't know if we can actually release this build. And it always feels like a gamble, like you're pulling a slot machine and it might blow up in your face. Probably the worst kind of slot machine you could have. Russian roulette might be a better analogy for that. And then it's also about having collaboration between the product side and the development side. So being able to create a roadmap such that at any point you've got your stories broken up small enough that you can actually release them and deliver real value to users. And if the product side isn't bought into this, you're going to get really large chunks of work that don't actually add any value until late in the game. And the other part that development can bring into this is being able to do things like feature toggles so that even if a feature is not yet ready to release, you can still deploy the code and maybe not turn it on quite yet. Another thing is cycle time. And this is one of the ones that on the development side was one of the most commonly heard pain points. The time that it takes to go from a commit to a deploy can be a huge pain for a developer because you push your code and there's like the XKCD about compiling. We have that at our client with build times right now where as soon as it goes to build, people get up and go play ping pong, which admittedly ping pong is a fun game, but it's probably not the most effective use of your time, and it's not getting you any closer to delivering real value to users. So things that go into this are having efficient testing, so getting feedback as quickly as you can. If you can run unit tests early in the pipeline that let you know that your code isn't going to work before you've done your longer running tests, making sure that your testing is structured so that each test runs as quickly as it can. If there are dependencies you can pass from pipeline stage to pipeline stage, that can be really valuable. Making sure that you're parallelizing your builds whenever possible, so long as it's appropriate. So if you've got a build that has to run on Mac and Linux and you can run those in parallel, that's going to save you a lot of time rather than waiting and just adding those on serially. And making sure you've got the right build resources so that whatever builds you need to run, you have enough agents, and having dynamically allocated agents can be really powerful for something like this. And this is where I'm going to pause and talk about a real-world case study. And like I said, this is my current project on the consulting side, so I'm happy to talk about this at length over beers later today. So to set the scene, we've got some technical challenges that we're dealing with. We walked into an environment with a monolithic code base that was really large. They had hand-rolled their own build system because they'd started working before a lot of the tooling for handling monolithic code bases and doing build systems around that was really developed. And so one guy who worked for the company was basically the only person who understood how this hand-rolled build system worked. They also had a lot of really unreliable environments because they were working, the nature of the domain meant that there are a lot of different dependencies that might be needed for different sub-teams, and they were using the same agent pool. And it meant that you'd get these spurious failures. I looked at some of the data we had for one of the projects that it's a high-performing team at this client. And I think a third of the failures when you looked at Jenkins were due to unknown causes. And basically the developer response is always just to re-trigger it and hope. They're like, yep, had a lot of failures, and I don't really know why, but we don't control the build system, we don't control the agents, I don't know what to do. And as I talked about, validating a pull request can take 8 hours, and 8 hours is actually kind of a good case in some of these times, which is disappointing as a developer. Because a lot of the builds, if you're touching something that impacts enough different components, the policy is you have to run what they call a universal pipeline launcher. So it tests a wide range of changes, and the goal isn't to have the whole pipeline go green. It's to have the same things go red that went red on master. So you have to do a 4-hour test run of master to see what your baseline set of failures is, and then do a 4-hour run of your own pull request. And if they all line up, you're good. So that was concerning. That definitely made, as someone who had to go through that cycle and then had one of those spurious environmental failures happen, and then had to do the same thing the next day, where I had to trigger another 4-hour run, I was pretty ready to pull my hair out, but fortunately I was empowered on this project to go try and solve that problem. We also had some organizational challenges, and I think technical and organizational challenges, is Lindsay's whole talked about, often go hand in hand. We had really tightly coupled code, but we also had really isolated teams. And it's been interesting, as consultants, we go in and we talk to a lot of folks, and you'll learn that people who sit about this far from each other never really talk. And they have the same problems, but they've never met each other, which is a little bit funny because they share the same rows. And they might even be dependent on each other. There's also, in this project, a wide range of maturity in testing. So one of the high-performing teams had, I think it was about 95% test coverage, and one of the other teams that actually had no one who was currently working on the code had no testing. And it was a PHP project that they didn't really have any PHP developers. So it was a little bit nasty to try and figure out how to migrate that build over. But it also meant that you were having the high-performing team was being held back from releasing by the weakest link. And there was no understanding of the build system, which meant there was no ownership by the teams of their builds. They just went and pinged that one person who obviously could never go on vacation because the whole company would stop. We also saw releases being routinely delayed or being done under the radar behind release management's back. So if you were that high-performing team and you needed to deliver something to your clients, you could either wait a really long time for the whole release cycle to go out, or just take advantage of the fact that you were confident in your release and go do it yourself. And what we saw was the releases being routinely delayed translated in one case to a particular sub-project being released. I think it was 10 months after development had completed, which meant that the first bug was reported a year after developers had stopped working on the code. And with the cadence of changing employment in the Bay Area, I'm not even sure if the developers who worked on that initially were still at the company. So that makes it really hard to be responsive to the needs of your customers. So what we did was we focused on 2 core things. We focused on the metric of reducing cycle time, and we focused on trying to increase reliability. So we extracted the services from the monolith. We've configured all of their pipelines as code that lives alongside the developer's code, and we've made really sure that each team has at least one person who owns that. We've paired with them, we've done onboarding sessions, and we've seen, it's been really awesome, the level of excitement when folks have been able to actually spin something up locally and not have to wait for the pipeline to test that and get feedback. And then they've also been able to make the tweaks that they've always wanted to make to reduce the cycle time because they know where their pain points exist. They've just never understood their build systems well enough to actually go fix them. We also, to address the environment reliability issue, which was adding to the cycle time by forcing reruns, provisioned all of their build infrastructure that we could using either Docker or Ansible. Ansible for the Mac agents, and then Docker for Linux and Windows. And I think the PowerPC is maybe the only thing we weren't able to apply this new way of provisioning agents to. And that one we kind of just had to say, there's not a good way to do this with Docker. And I pulled out a couple of the results. I've got plenty more. I just didn't want to spend the whole talk giving you numbers about this. In one case, the cycle time for one of the largest components we've extracted was about 4 to 5 hours on average, and now it's an hour and 23 minutes, which is still long, but a big savings. And then the second one, the number of deploy-ready builds for the high-performing team I was talking about that had 90% code coverage, they were releasing anywhere from every 3 to 8 weeks, and I think there might have been a couple cases that were even longer. And now they can release weekly. They've got it set up to do automated releases every time they've got a code change. And they don't release if there's been no code changes between the week, but they're automated going out with any sort of human interaction. So their cycle time and their number of deploy-ready builds has really improved. To move on to talk about some of the other metrics, these two about failure that I was talking about, I'm kind of pairing hand in hand because I think that it's important to balance between the two of them. So mean time between failures, you see this novice who's running hurdles and has run into every single one. Just every easy barrier that you could possibly go over just crashes into, crashes into, crashes into. And instead, we'd like to not fail all the time. I want to caution, though, that trying to avoid failure completely is not the right approach. And that's why I have mean time to recover as the other metric in this section, because one very obvious way of gaming this metric and never failing is just don't ever release anything new. That would be an approach, but probably not the right approach if we think that the core point of software development is to provide new value to users and make sure that we're serving their needs. So what goes into this is having quick feedback early on, making sure, as I said before, that you get validation in your testing environments. We saw a diagram in the first talk of having your dev, your stage, and your QA, and your prod environments, making sure that you've got all of these stages that get increasingly more realistic and more true to life, rather than waiting until you get to prod and you like test in prod and hope it works. Not a great approach for avoiding failures. You need to have faith in those validations. So what I was saying before about our client where they would run these 4 hours of test suites or run them twice and never actually know if the code was good, that's obviously a problem for maximizing the stretches of time you go without failure because you're playing Russian roulette. And having strong local builds is another part that's really valuable for this. So making sure that your environments locally are as similar as you can make them to your actual production environments is pretty key for this. The other part is if you're trying, failure is inevitable. So making sure that your mean time to recover is as good as possible. How long does it take to get you back to a green build after you've had either a pipeline failure or after you've had a release that's failed? One thing that goes into this is making sure you've got robust monitoring of your production. So as I said at the start of the talk, you want to make sure that the way you know there's been a failure is through your monitoring and your alerting, not because some user calls you up and says, hi, I was trying to order this ticket and my order didn't go through, what happened? Because there might be some words that, again, I'm not allowed to say on stage that come through on that end, and you might lose a customer. You also want to have either an automated rollback process or a really good idea of how to roll forward. And that having an automated rollback process is nice because it buys you a little bit of time to understand where the issue occurs. Part of understanding where the issue occurs is having really informative logging. So being able to, when you get paged and it's 2 in the morning and you're kind of blurry, you don't really know what's going on, it's great if your logging can tell you where the problem is. And all of these things, making sure that you've got these robust systems and that these are things you bake in from the start is really important to being able to get back to recovery, back to a green state as quickly as possible. Again, I want to talk about a case study here. Again, there's going to be some common patterns. I think while no struggle looks exactly the same, there are common themes that you see. So having large code bases is often a source of problems. In this case, the client had 1.27 million lines of code. There's a high level of cyclomatic complexity. There were really tightly coupled systems. They had this big testing suite again that I don't think had ever gone green, at least not in the memory of the people that we talked to. So it was very unreliable, but it existed. So that counts for something, right? And that kind of attitude towards testing, I think, is unfortunately rather common. Like having tests there, even if they're never green, is still somehow seen as valuable. The organization had, again, really isolated teams, folks who weren't talking to each other. They had long periods of waiting. They had a lot of queuing that was happening, both on the build side and on the organizational side. And there were a lot of really inefficient handoffs, again, between teams that worked together closely enough and had been at the same company, and so should be able to communicate fairly easily, but for a number of reasons weren't. In this case, we didn't come in with quite the same mandate of like, these are the 2 metrics we're trying to fix, this is the way that we're doing it. So what we did was we had each team map their path to production. We did a workshop that got a bunch of teams together, those teams that I was saying often relied on each other, but didn't necessarily interact very much. And as they mapped their path to production, again, make an investment in 3M. It's a great tool for trying to improve your software delivery process. We mapped those all out, we highlighted areas for improvement, and then we had each team share their results across this organization, and then both individually and collectively, they would brainstorm ways of addressing these pain points. And these were things, as soon as you sit folks down and you say, hey, we want to talk about where the pain is, I'm sure all of you, if you were to run through this exercise very quickly, go from, what does it take for the teams that I work with to go from commit to production, you can highlight almost immediately where the pain points exist. And you've probably already got ideas that you've never been given the license to actually experiment and try out. So people are super excited about this process. And they brainstormed some solutions, and we did some ranking of what's actually feasible, what's too maybe ambitious, where can we make easy, quick wins. And one thing that happened was there was a rewrite of the test suite. There was increased automation, so trying to reduce some of those manual handoffs and manual kind of check steps. And we finally got the build screen, which is an important step. And the improvements that happened, we saw a decrease in the cycle time from 18 days to 10 days. And 10 days still leaves some room for improvement in the same way that, as I talked about before, maybe having an hour and 23-minute build isn't necessarily where you want it to be, because it still requires the developer to go either context switch for that hour and a half almost, or just wait. But I wanted to highlight some examples that show that even making incremental progress is really important. The pipeline run duration decreased from 10 hours to 15 minutes. And the 10 hours was with that full regression testing suite that actually wasn't ever fully green, and so didn't really mean much anyway. And then mean time to recover, because it was always red, there was no mean time to recover. It was just always red. And now 50 hours again, maybe not quite where we want it to be, but definitely an improvement. And having that improvement has created organizational changes too, because now that people have seen things can in fact go green, they're actually excited about trying to make them green. And there's some degree of buy-in to this idea that maybe we can do better. And so the teams have a greater sense of ownership. One other thing that I think is really cool in this team is that they created a dashboard to show where things go. And unfortunately, the text is a little bit small below, but it talks about how many runs are happening per day and whether they're green or red, how long those builds are taking, and again, whether they turn green or red. And you can see the time to fix the failing pipelines runs has decreased significantly from that old outlier. I think that's hovering around 1,000, and now everything is under a couple hours. And then there's time from code commit to package deployment. And by having these in a visible way where the team can actually consult them, again, it's a little bit easier to care. If you think back to that quote, you can improve things that you can measure, you can improve things you can see. And so having a dashboard like this and putting it in an area where the team can see it and feel a sense of ownership and a sense of connection is really valuable. On the other hand, I don't want to say that metrics are a panacea. There are definitely some meaningless metrics, and this is something I'd love to discuss also over beers. I gave a shorter version of this talk at DevOpsDays Denver and got some great stories about things that have worked really well and things that fell completely flat. To the flip side of the quote before, the company will build whatever the CEO decides to measure. And I'm sure everyone can kind of think already about what that might result in. I happen to like climbing, and I like this mountain because the KPIs are pushing you off a cliff, or maybe they make you want to throw yourself off a cliff because you feel like your company's just trying to optimize for the wrong thing. For example, lines of code written. And in this comic, it says, Sally, your output isn't cutting it. You only produced 15 lines of code. Oh, were you referring to the 15 lines of code that cured cancer? Yeah, 15 lines of code just isn't enough. We really need more. And this is actually something that someone at DevOpsDays Denver told me they had been measured on. It happened that there was this cute little comic that I did not have to make, but this was a real metric that someone thought was valuable as a way of understanding how well their team was performing. And to me, this just feels absurd. And I think the comic highlights that absurdity because what we should be concerning ourselves with isn't how many lines of code we're writing. Someone kind of quipped at the same meeting that maybe it should be the lines of code deleted because that'll at least increase maintainability. Obviously, also problems there. But what we should be focusing on is trying to deliver value to our users. Another one, classic Dilbert, number of bugs resolved. Our goal is to write bug-free software. I'll pay a $10 bonus for every bug you find and fix. Yahoo, we're rich. Yes, yes, yes. I hope this drives the right behavior. I'm going to write me a new minivan this afternoon. So I think this one, too, is clear. And this is, again, a real metric that someone told me about that they had been measured on, and that was how their performance was being evaluated. And there are two problems. One is this obvious problem of you can just write yourself a bug to then go fix and then go make $10 and just repeat, become rich, and quit your job with all these bugs. The other one is that the number of bugs is not really what we want to be solving. We want to be trying to incentivize people also to tackle tough bugs, not just the low-hanging fruit of like, oh, there's a typo on this page. That counts as a bug, right? Like, I'm going to go fix that and check one off. You want to be incentivizing people also to look at hard problems and look at where they can be creating meaning for the organization. This was one that we had a client who tried to propose that we get measured on this, as would their team. It was developer hours per story point. And this one maybe is a little more controversial because I know some people really like velocity as a measure. And I think that it does have its place to do relative sizing. But there are also areas where it just falls flat. And so the comic says, we have to increase velocity. Increase velocity? So bigger estimates? Definitely bigger estimates. And I've actually heard this one come up in a couple cases. For me, it was that they wanted us to track every half hour we spent working on code and then track every story point we completed. And then we'd figure out this very objective developer hours or half hours to story point ratio. And then we could, like, I guess, compare the developers and see who was the best developer or something. I've also heard of cases where two teams were doing like a competition where they were trying to have the highest velocity, and the client who came up with this idea like patted themselves on the back for having this really objective contest that there was no way it could be gamed. So again, fairly obvious way this could be gamed, but also something you see play out in real life. And there are also cases I know of where firms are operating on a guaranteed velocity is how the contract is set up. And story points, if people don't buy into them, tend not to work very well as a way of measuring how a team is doing. In all of these cases, what's making these metrics meaningless is that there's a lack of team buy-in. You can see this play out in every single one of those comics. And honestly, this could be a problem with, like I said, mean time between failures, these metrics that we came up with. If people don't buy into them and don't see them as being valuable, you can always come up with a way to game them. And I think those comics were great because they gave me very obvious ways, but you can see all kinds of places where the same behavior plays out. They have unintended consequences. If you think back to that Sam Altman quote, this idea that a company will build whatever its CEO decides to measure, the same thing with managers. If you pick a metric and that's the only thing you focus on and your team doesn't buy into it, you're never going to see any value out of it because people are going to be optimizing so locally for that metric, they're going to forget about delivering value to the customers or making sure that we're building code that's easy to maintain so that if you do get a bug report a year after, you can actually go back and find that cause really early on. Another issue is oftentimes metrics, just because it's easier to measure these things, will elect to measure inputs, not impact. And that can be a problem because you've seen, like lines of code written has no correlation to cancer cured in that fairly extreme case. You want to be picking things that address the values you're trying to see. And that's why we, for the second example in particular, really tried to create buy-in from the teams and get them invested in the process of creating the metrics and deciding, where is your biggest pain point. In the first case, we just knew so clearly that that was their biggest pain point. That was what we had been told over and over again initially. And so it was a fairly clear point. And I saw that with every case as we got new teams set up, like even the ability to just run the make targets that would be running on the system and have a Docker environment spin up and do all the testing locally, people got really excited. And it definitely has made our job a lot easier when the developers feel like they're doing work that matters, where they're solving their own pain points. So I want to encourage you all to make your own metrics that matter, to think about what you can be doing that'll address those pain points you have. So one exercise you could do is map your path to production. You can highlight those pain points the same way that we did. You get people together, you collaborate, and you experiment. Another really cool case that I've heard about was someone who they felt like they kept having cards that were moving back, like they were using Jira, and they would have cards that would just sit in a particular column for a while. And every time it was getting blocked, you write a little message. And they had all of these different teams who were writing messages talking about where they had, what their reason for being blocked was, whether it was a dependency not being ready or some environment issue. And when they had a hack day at their company, they wrote something that would scrape all of those comments and do a meta-analysis and just look for kind of a word cloud. What are the most common themes that you were seeing? Because they felt like there had to be something there. And so they had this awesome internal data source that they were able to see what are the top 5 causes that we're experiencing. Why are the builds why is our cards getting stuck in a particular column? And that was just something that they'd very organically felt as a pain point. And so their metric was trying to reduce the amount of time that cards got stuck as their way of reducing their cycle time and being able to deliver more effectively. So again, whatever it might be for you, map your path to production, highlight your pain points, do this collaboratively both within your team and across a number of different teams. Do some experiments, see what works out for you. If it doesn't work, you can always try something new. That's a core part of our ethos in general. And if all of that seems really hard and you just want an easy place to start, I'd encourage you to take a look at these metrics and try and understand, how are your deploy-ready builds doing? Are you committing code to master as routinely as you can? Are there any pain points in your cycle time where you could be moving faster or, optimizing your testing, any of those sorts of things? Are you seeing a lot of failures, just running into hurdle after hurdle after hurdle, where there are obvious ways of maybe jumping for once? And then when you do have those falls, when you do release something that has an unexpected failure, how long does it take you to recover? Can you quickly identify the root cause? Or are you just getting stuck from 2 until 7 in the morning trying to sort out the issue because you have no idea where it exists? And look at each of those things. Look within your team. Talk to other teams, because it's quite likely that if you're having this problem over here, that team's having the same problem, as is that team. And maybe just none of you have actually talked to each other because your organization's gotten to the part where it feels too big to actually know anyone who sits around you.